complicated calculating machinery that we have used about 150 valves or thermionic tubes. When Tommy Flowers got his brain in gear, he came up with a design for a machine which was the Colossus Mark I, which used 1,500 valves. In fact, the powers that be here at Bletchley Park looked at the design and said it'll never work because valves are far too unreliable. Those of you who may be able to remember the old valve-driven radios, on off, on off, on off, bang, valve goes. Why? Because it's constantly switched on and off. Tommy Flowers has been designing repeater stations for years using valves, and he knew a thing or two about valves. And he knew that if you switched a valve on and never switched it off, it would last for years. In fact, that grey valve that you see there, when we put it in this machine here, we looked at the date on the bottom, 1943. Date of manufacture. It's still going strong. So, Tommy Flowers also recognised a couple of other facts. The tape that you saw when we were in the other room this perforated tape, which is what Colossus works on, has down the length of it a whole series of holes, and those holes are at a specific distance from each other. Now, Tommy realised that he could do two things. If he put memory circuits in this machine and then made the reading head and the circuitry to read those holes, he could use those as timing for the machine and hence set the clock speed of the computer from that. And because it had memory circuits in, he didn't need the second tape that Robinson used. He could work on just one tape. So if the tape feed speeded up, Colossus would speed up. If it slowed down, Colossus would slow down because it was getting its timing from the tape itself. Now if you listen to this machine, it's clicking once, twice, 3 times. In that time it's completely read and analysed that tape that's going around there. It's going through the reading head. Again, that was designed by Dr. Arnold Lynch, who designed the reading head for Robinson. But instead of working at 1,000 characters per second, that is reading at 5,000 characters per second. In fact, that tape is going through at a linear speed of about 30 miles an hour. But this doesn't use a stored program. It uses a switched program. So what the operators had was virtually a flowchart. So what they had, they would load the tape onto here. They would then set these switches here as controls according to their flowchart. They'd then go over to this bank of switches and set those according to the flowchart. They'd then set these plug sockets, which were an initial guess at what the wheel start positions were. What Colossus is working on, unlike Enigma, which works on 26-letter alphabet substitution code, to break Lorentz, we had to work pure mathematics. And the maths that this works on is Boolean mathematics, which involves basically ones and zeros. And what Colossus is doing, reading this tape, it's looking for the number of occurrences of one specific Boolean function that it's reading from that tape as set by these controls. And these decade counters here make a note of that count, and that count is displayed on this readout here, set in thousands, hundreds, tens and units. Once that count had reached a maximum, the operator could output that information to the printer here. She would then reset the switches according to her flowchart, and what Colossus would do was then analyse that tape again for a second Boolean function, because the first Boolean function was the patterns and positions of the first Lorentz wheel. She would then reset everything. It would then analyse it again, looking for the patterns and positions of the second Lorentz wheel. Once it had all 5, we could work out the remaining 7 by hand. But that was only the Mark I. Whilst the Mark I was being built, Tommy Flowers' assistant, Alan Coombs, was working on a much more powerful version, the Mark II, which used 1,000 more valves, 2,500 valves, and that machine found the patterns and positions for all 12 Lorentz wheels. The first Colossus machine came up here to the park in December 1943 and was housed in Block F, which unfortunately no longer exists. That was knocked down by the post office in the mid-1980s. And when the powers that be saw this working, they said, great, we'll have another 10. So much for their idea, oh, it'll never work. Yes, in actual fact only 9 were delivered. The extra 10th one was in production when the war finished. There were 5 down in F block, which is on that huge patch of empty grass down in the middle of the park there, and 5 were in H block here. In fact, where we are now, this is where Colossus number 9 sat during the Second World War. If we come forward a few decades, Tony Sale, whose background has been in computers for years, always wanted to rebuild Colossus. But where do you start? Well, in 1992, when the Bletchley Park Trust was formed, around 92-93, he got himself a whole bunch of angle iron, a can of grey paint, a Black & Decker, and said, right, where do we go from here? Because at the end of the war, everything was destroyed, allegedly. The order came down from Churchill, destroy everything in Bletchley Park. Well, he managed to find about 8 or 9 original World War II pictures that had been kept by the engineers, which they shouldn't have. And in fact, there's 1 or 2 on the wall there. You can see a circuit diagram on the wall. He managed to unearth 2 or 3 circuit diagrams from the engineers, which they shouldn't have had. Engineers being engineers, God bless them, they had little notebooks of information which they kept, which they shouldn't have done. And he managed to contact quite a few of the engineers who'd worked on Colossus during the war. Tommy Flowers and Dr. Arnold Lynch were also still alive at that time. So they all got together in Tony's workshop, got his CAD system fired up on his computer, and they virtually reverse engineered Colossus from the information they had. And they rebuilt it, and 14 years later, here it is, a rebuild of the Colossus Mark II. But for this to be classed as a rebuild and not just a mock-up or an imitation, it has got to consist of a very, very high percentage of original parts. Where do you get those from? Well, when Tony started building this was at a time when the GPO were getting rid of all their analogue exchanges. So, what happens? Digital equipment's coming in the front door, the old analogue equipment's going out the back door, and there's Tony's van parked saying, load it on guys, we'll recycle it for you. And of course, here it is. When Tommy Flowers wanted a part, he went down to the stores, he got a standard part off the shelf. That's what this is. And as far as we know, this is about 95% accurate rebuild of a Colossus Mark II. And to prove that it works, in 2007, Tony set up what he called the Cypher Challenge. And that was, we took our own Lorentz machine from our main museum over to the Heinz Nixdorf Museum in Paderborn in Germany. And there they coded up a message and broadcast it over the airways worldwide. And the challenge was, intercept that message and break it. And we'll see who does it the fastest. Well, after a couple of false starts due to a valve blowing and bad atmospherics, we actually picked it up here at the park on the equipment that you saw through in the other room. We punched up a tape, we put it on Colossus, we got the 12 patterns and positions for the Lorentz wheels, we then put that tape onto the Tunney machine, we decoded the message, time taken about 3.5 hours, as it took during the war, for the average message. So we then sat back and said, right, let's see if anybody breaks it. Did they? Oh yes. Who was it? A German. His name was Joachim. He lived in Bonn, just round the corner from Paderborn, and he broke it in the fastest time. And when he came over to collect his prize, he did point out that whilst Colossus is reading characters at 5,000 per second, he was using the latest Pentium-powered computers, crunching numbers at 1.2 million per second. He was also a software writer, and he'd written his own programs to do this in ADA or ADA, high-level computer language. But he did a few more calculations, and he worked out that factoring up the clock speed that Colossus was working on compared to what came after, in 1945 Colossus was working faster than many of the commercial computers that were being produced 20 to 30 years later. It was an incredibly fast machine. It was digital. It was semi-programmable. It was parallel. It was fast. Very, very fast. Which says, I think, an awful lot for Tommy Flower's design on the Mark I and all of the work that Alan Coombs did on the Mark II. Oh yes, Joachim's time to break the message, 47 seconds. Just think what we might have achieved here in 1945 if we'd been using Pentium chips. But here it is. The world's first semi-programmable digital electronic computer. Unfortunately, we've only got one of them. We cannot leave this switched on as it was during the war. When each Colossus machine was installed, it was switched on, and it was left on for the duration to conserve life on the valves. The only times they were switched off were for routine maintenance. We don't have that luxury because each one of these machines put out 5.5 kilowatts of power. In fact, Block F and Block H in winter were the two favourite places in Bletchley Park because of the heat. In fact, we do have it on record. It is said that it got so hot in here that the female operators used to doff their blouses and their skirts, and they used to work in their undies. No wonder the code breakers were racing to see who could be first to bring the messages over here to get decoded. But it got very hot. We can't afford that luxury because we can't afford the electricity bill. So just round the corner we've got a piece of machinery called a variac, and at the end of each day we take Colossus down very slowly, cool it, and then first thing in the morning we bring it up very slowly to conserve the valves. At the moment we're going through about 8 to 10 valves a year, and we've got enough to last us probably for about the next 10 years. So if any of you have got any old boxes in your loft, under your beds, in your garage, of any old World War II valves, we can use them. What we're going to do in 10 years' time, well, we'll cross that bridge when we get to it. Unlike Bletchley Park, the National Museum of Computing here is a completely separate entity. Although we're on the same site, Bletchley Park has its own board of trustees, and the National Museum of Computing has its board of trustees. So any money that the park gets in, the museum here doesn't benefit from, and vice versa. In fact, several months ago, somebody in a tour said, here's a question, how many people do you reckon in the UK either own or use computers? And the answer was, well, thousands, tens of thousands. So he said, well, what if everybody in the UK who either owns or uses a computer was to donate £1 to the National Museum of Computing? That would allow them to do everything they need to do and set up an endowment to keep the museum open for everybody in perpetuity. And this is where I have to discreetly point at little blue boxes that you will find knocking around the place. Thank you very much indeed. Thank you. Right, we're just going to finish up the tour. Well, we have run a bit over time. We normally finish up the tour outside of Hut 8. Yeah, we can.